Okay, today we're graphing exponential growth and exponential decay problems. So let's look at it. Yesterday we learned that growth and decay have the same formulas. The only difference is the number inside the parentheses is bigger than 1 if it's growth, and it's smaller than 1 between 0 and 1 if it's decay. So yesterday we had this formula. We had the A, and then we had 1 plus R. See, 1 plus R makes it bigger than 1. If you add something to 1, it's going to be bigger than 1. And yesterday we had this formula for decay, 1 minus R. And then, of course, if you subtract something from 1, it makes it smaller than 1. Right? So if the number inside the parentheses is smaller than 1, it's decay. So see here, I've got a big number, but inside the parentheses, the thing that I'm raising to the power, that's a fraction between 0 and 1. That means this one's decay. This one is greater than 1. It's like saying 1 plus a half, right? This is like saying 1 minus a half. So we know that this one's decay and this one's growth. So how do they look? What is it that how can we graph these guys? Well, we can we could make a little table like this, and I'll show you how to do it on your calculator. But if you put 0 in, 1/2 to the 0 power, you remember that anything to the 0 power is 1, so to the 0 power, this would be 1 times 8. That'd be 8. And if I put 1 in there, 1/2 to the 1 power is just half. So 8 times a half, that'd be 4. And if I put 2 in there, 2, I'm squaring a half, that'd be 1/4. So 1/4 times 8, that's 2. And if I put a 3 there, 3 would make this 1/8. Crazy, huh? So that'd be 1. So what am I doing, just to show you one more time, that I had 8 times 1/2, right? Because when I put 1 in here, I get that. 8 times 1/2 squared is really, 1/2 squared is really 1/4. So 8 times 1/4, that's 2. 1/4 of 8. And then 8 times 1/2 to the 3rd power, 2 to the 3rd power is 8. So really, 8 times an 1/8 is 1. Right? So what's happening in my picture? 1, 2, 3, 4, 5, 6, 7, 8. I have a graph. 1, 2, 4, 6, 8 right here. So here is 8, 0. And then if I go over 1, I'm going down 4. If I go over, I'm down to 2. If I keep going over, I'm down to 1. The next one would be 1/2. What happens is there is an asymptote right here. That's a P, asymptote. And it's a barrier. This graph comes from above, and it comes down, 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 and it gets closer and closer and closer and closer to the asymptote, but it never, ever, ever crosses the x-axis. It's never equal to 0. There are no x-intercepts. This guy never crosses the x-axis because it never, ever, ever can get down that low. There's an asymptote there. So the y values are always positive, and see over here, if this one's 8, this one's bigger than 8, right? So if I did -1, -1 would make this 2 times 8. That'd be 16, way up here. Right? That's the whole idea. So it starts high and it goes low. That's what decay means. It's getting smaller and smaller and smaller. So when you graph it, you need to know that there's an asymptote. Both of these guys have asymptotes right at the x-axis. You never can get lower than the x-axis. Right? And then I'll show you how to graph this on the calculator. And we will be happy. Let's do this one. Okay. So I go to y equals, and I go to zoom, zoom, zoom. Oop, I need the light. There we go. Too much light. Too big of a light. There we go. Maybe we can move it over here. So, what did I say? I had 8 parentheses 1/2. So 1 divided by 2 raised to the x power. Now then, if I look at my table, if I start at 0, whoops, what am I doing? Okay, clear that. 8 times 1 divided by 2 raised to the x power. Now we're cooking with gas. Okay. Now see, it's like I said, I had 8, then I had 4, then I had 2, then I had a half, and a fourth, and an eighth. And if I go -1, it's 16, -2 is 32. It gets big on the negative side, small on the right, on the positive side. And we can look at that right there. See, there's my graph. It's just like this one, right? If I want it to look exactly the same, I have to change my window so I don't have any negative parts. So let's make this -5. And then I go all the way up to, oops, wrong way. Nope, that's right, -5. I go all the way up to that. And let's see. Here's my picture. It looks just like this one, see? And it gets closer and closer and closer and closer. And we looked at that. We said, oh, look. As I get closer, I'm down here to 4, I'm at 1/2, and then I'm at 1/4, 0.25 is 1/4, and then I'm at 1/8. I keep getting smaller and smaller. This is 1/16. I'm just getting closer and closer and closer to 0, but I never ever reach 0. It gets down there, but it's going down always, but it never reaches 0. Because there's an asymptote. Going down always, but it never reaches 0 because there's an asymptote. So let's look at the other one. Okay, so this one says 8 times 1/2, 1.5, raised to the x power. Now remember, this is a growth problem because this is bigger than 1. So I'm going to expect that 1, 2, 3, here I got 1, 2, 3 getting smaller and smaller. Now I'm expecting it to get larger and larger. So if I look, 1 is 12. And how can we count that? Let's count by 4s, okay? So this will be 4. And then this will be 8. And this will be 12. And this will be 16. 20, 24, 28. And 32, and it just keeps going up from there, huh? Okay, so I have 0 is at 8, because remember, this is your starting point, so you always start at that starting point. When you're over 1, when I go over 1, I am at 12, and then 2 is at 18, and then 3 is at 27, which is way up here, and then 4 is at 40, which should be way up here, right? And what's happening on the other side of the world? At -1, I'm at 5. At -2, I'm at 3.5, and 2.25, and 1.5. So what's happening? My graph is going like this. Yeehaw! Right? Growth goes up to the right. Growth goes up to the right. and decay goes down to the right. So this is up to the right. It has an asymptote right at the x-axis. Right, the x-axis is the asymptote. So this gets closer and closer to the x-axis, but it never ever equals 0. It's little fractions or decimals as it goes up. This one's the same way. This one goes down to the right. Down to the right. And it gets closer and closer, little fractions, closer and closer to the x-axis, but it never ever equals 0. So when you graph things, that's what you have to do. Now, you should know that the domain is all real numbers, and the range on both of these is only positives. Only positive, right? The domain, how wide is this graph? Well, this goes to the right forever and goes to the left forever. Right? This gets getting bigger and bigger. If I pick another number here, it's bigger. Another number bigger. Another number bigger. Right? Same thing here. This is small on the left, big on the right. Right? So the domain and range are the same for all of them. There's an asymptote on all of them. And just decay goes down to the right. Growth goes up to the right. That is graphing. And we're done. Bye.